Good morning, guys. Today we are back with another problem, and today's problem is constructing a matrix with size n and n, which is a given integer q, and the value of each of the set is given as m of I and j is I plus j. Okay. So if I have to suppose if I see the matrix is 2, 3, 4, and 5, and the second element of the matrix are 3, 4, 5, and 6. Okay, and the fourth element is 4, 5, 6, 7, 5, 6, 7, 8. So what I have to basically do is they will be giving me a number, say for example q equals 7. So and the matrix is formed in such a way, so I'm just going to quickly put the rows and columns of this particular matrix. So I'm going to mark this by red. Okay, so this is 0, 0. Okay, 0, 0. So if I mark the matrix elements as 0, 1, 2, 3. Okay, then 0, 1, 2, 3. So for this particular matrix, okay, 0, 0. So for this particular matrix, it is 2. Okay. So let me just clarify, because they have started the numbering from just a second. They've started the numbering from 1. Okay. So for this, I can do the numbering from 1 as 1, 1, 2, 3, 4, 2, 3, 4. Okay, so 1 plus 1 is how much? 2. Okay, 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Okay, this is how you have to mix. You have to do the sigma. Which is summation of I plus j. I and j are nothing but the index. Okay. Similarly, if you are making this 1 plus 2, 3. 2 plus 2, 4. 3 plus 2, 5. 4 plus 2, 6. Similarly, for this one, it is 3 plus 1, 4. And 2 plus 3, 5, 3 plus 3, 6, 4 plus 3, 7. Similarly for this one, as 1 to 5, 6, 7, and 8. Okay. Now you have to see, they have said that you have to give a given number 7. So how many times this particular 7 is occurring within this matrix? You can see 7 is occurring once and twice. So the output equals to 2. So this is what we have to do. Okay. So how we are going to do this? Okay. Supposed to tell us that you can see this is a matrix. Okay, so in this particular matrix, what will be your smallest point? So if I see my smallest point will be what? This particular element plus this particular element. So I can say 1, 1 is my smallest point, and what is my largest point? Say for example this particular element, which is 4, 4, or 4 is the size of the matrix. So I can say largest point equals to n, n. So if I sum up the value of q, so my q is nothing but I plus j, so it becomes 1 plus 1 is 2. Similarly, n plus n equals to 2n. Now I'm going to derive some cases. Okay, I'm going to derive some cases. So over here, let's analyze this particular problem by deriving some cases. Okay, so you can see clearly that we have a small value which is coming as 2, which we have studied now. Okay, and also similarly we have a largest value which is coming as 2n. Okay, so now the given is I plus j is q. Okay, so our first case is when q is between 2 and n. So I can write 2 less than equals to q less than equals to n. So this is the condition, first condition. So we are taking an example in order to study the first condition. Suppose we are taking q equals to 3. So what can be the valid pairs? The valid pairs is nothing but 2 plus 1, 3, and 2 plus 1, 3. So when you are adding these pairs, you can see it is coming up to 3. But should we take 2 pairs? No. We are going to take only 1 pair, because if you see 1 and 2 and 2 and 1, these pairs are not unique. But if you take only 1 and 2, it's like not allowing repetition. So we are only taking 1 and 2. Now we can generate a pattern. If you see 1, it becomes first is 1, then again q is 3 minus 2, so it is 1, 2. Then suppose you are going to 2, so it is like 3 minus 2, it is 1. So say for example I'm taking q equals to 3. What can be the pattern which I can generate? So the pattern is q minus 1, 1. So the pattern is 2, 1. How I am getting? By this formula. So first pattern, what I can see, 1, q minus 1. So what is the value of my q? Which is 3 minus 1, so 2. So 2, again my value of 3 minus 2 is 1. Okay, so 3, next pattern is 3. So 3 minus 3 is 0. Okay, so what I can see, this is the one I can get. This is the one I can get, which is valid pair, because 0 I'm not going to take. We can't go. Our coordinate is still 2. Our coordinate is still 2. Why our coordinate is still 2? Because I've already told the matrix is starting from 2. Okay. Similarly, let's come to case where q is between n plus 1 and 2n. Q is between n plus 1 and 2n. So I'm going to write this. How I'm going to write this? So I'm going to write this like q is between n plus 1 and 2n. So you can see my q minus n plus 1, q minus n plus 2, n, my comma, q minus n. So this is the formula which I can pretty much generate. Okay, so say for example, I have an example q equals to 7 and n equals to 4. So what is the formula I'm getting? So the formula will be 4 comma q minus 4. So 4 comma, 4 comma q is 7 minus 4, 4 comma 3. So this is the formula I'm getting. Okay, so we can see whenever the q equals to n plus 1 and the starting point is 1 comma n to n comma 1. So as the q value increases, starting point also starts shifting. So we can derive this formula 2n minus of q plus 1 for this particular case. And if this is out of the range, if q is out of 2 comma 2n, we will return 0. Now in the algorithm, what we have used is 2 less than equals to k, q minus 1, which I have already told you. For n plus 1 and q, the formula is 2n minus q plus 1. So 2n minus q plus 1, don't get confused. This is the formula because the higher limit is 2n minus of q plus 1. Why we are using minus of q plus 1? Because you can see over here we are using n plus 1. This is the formula we are getting over here, q minus n and all. So this is how the formula is derived. Okay, so let's analyze the code once again. Sorry, this is this was our yesterday's problem. So if you see the code, we have clearly written that q is less than equals to 2. We are using q minus 1 formula. For the range between n plus 1 and n less than equals to 2, we are using 2 into n minus q, or else we are returning 0. So this was today's problem, and I hope you could understood the explanation. Thank you.